In this video, we'll take a look at the different properties of trapezoids. So a trapezoid is a quadrilateral with exactly one pair of parallel sides. The parallel sides are called the bases. You can see here our parallel sides here are our bases, and the non-parallel sides are our legs. The base angles are formed by the base and one of the legs. So A and B form a pair of base angles, these two, and then C and D also form a pair of base angles. If the legs of the trapezoid are congruent, then it's an isosceles trapezoid. So if these two are equal to each other, the legs, then it's called an isosceles trapezoid. So if a trapezoid is isosceles, each pair of base angles is congruent. So all these theorems we're looking at here are for isosceles trapezoids. So if we know it's an isosceles trapezoid, meaning the legs are equal to each other, then each pair of base angles is also going to be equal. So G and H are going to be equal, and F and J are going to be equal to each other. If a trapezoid has one pair of congruent base angles, then it is an isosceles trapezoid. So if we know that one pair is equal to each other, then we can also say that it's isosceles. So the the legs are equal to each other. If a trapezoid is isosceles, if and only if its diagonals are congruent. So the diagonals must be congruent or equal to each other. So Q, S, and RT must be equal to each other for the trapezoid to be isosceles. Let's take a look at the proof for that. So if we're given an isosceles trapezoid, so we know already the trapezoid is an isosceles trapezoid, we want to prove that our diagonals are equal, so that AC equals BD. So what we can do is we can say AD and BC, these two are equal to each other because that's our definition of an isosceles trapezoid. So they're equal. And then we know that ADC, this angle, equals BCD, this angle. Again, that's our definition of isosceles trapezoid. So base angles, right, are equal. AD and BC are equal. And then we can say DC equals CD. So this line right here equals itself by the reflexive property. So then we can take a look, and we have two different triangles here. We have ADC, this one, and we have BCD, this one. So they're going to be equal by side, angle, side. We have a side, angle, side, side, angle, side. So then by corresponding parts of congruent triangles are congruent, we can now say that our diagonals, which are the other side, the corresponding sides of the two triangles we just constructed, are equal to each other. Let's take a look at a couple of examples. The speaker shown is an isosceles trapezoid. If the angle FJH, so this one here, is 85, so we know that this angle is 85 degrees. FL is 8 inches, and JG, so this whole big thing here, JG, the whole diagonal, is 19 inches. We want to find each measure. So FGH is the first one that we want to find. So we know FJH is 85. And then if we want to find FGH, so we want to find this angle right here. We want to know what that angle is. So we can also say that GHJ is 85 because our base angles are going to be congruent in an isosceles trapezoid. So if this one's 85 and these two are parallel, then this angle, the one we're looking for, and this one are going to add up to 180 because they are consecutive interior angles. So we can say 85 plus, we'll just call it angle G for now, for FGH, G equals 180. So 180 minus 85 to get G by itself equals 95, so 95 degrees. And that's our answer for that one. And then LH, if we want to find LH, so let me erase what we've written here so far. So LH, we want to find this part right here. So we know that this whole part is 19. We know this part is 8. And we want to find this. We'll call this part x. So if our diagonals are equal, then 8 plus x, which gives us the diagonal, equals the 19. So 8 plus x equals 19. And then we can subtract 8 from both sides. We get x equals 11. Okay, let's take a look at another example. So if we have these vertices, these 4 different points, we want to show that it's a trapezoid and determine whether or not it's an isosceles trapezoid. So to show that it's a trapezoid, what we'll want to do is look at the slopes of the lines. So let's look at AD and BC. We'll calculate the slope from A to D. So D is here. Our slope equals y2 minus y1 over x2 minus x1. So our y2 would say 0 minus 4 over our x2 is negative 1 minus negative 3. So we get equals negative 4 over, and negative 1 minus negative 3 is negative 1 plus 3. Negative 4 over 2 equals negative 2. And then let's take a look at B to C. So B to C, our y2 minus y1 is going to be 3 minus 5 over x2 minus x1, 3 minus 2. So we get negative 2 over 1 equals negative 2. So our slope for AD and BC are equal to each other. So then we can say it is going to be a trapezoid because these two are parallel. Now we could calculate the slope between AB and DC the same exact way, and we would see that the slope of those two lines are not equal. So those ones are not going to be parallel. So we only have one pair of opposite sides that are parallel, so it is a trapezoid. Now we want to see if our legs are equal to each other. So does AB equal DC? So we'll use our distance formula. And you could also put this into GeoGebra to calculate the distance. But let's use our distance formula. Dist equals, so our x2 minus x1 squared plus y2 minus y1 squared. So if we look at A and B, we have, let's substitute into our formula. So x2 is 2 minus negative 3 squared plus y2 is 5 minus 4 squared. Okay, so 2 minus negative 3, that's 5 squared plus 1 squared equals, and we're taking the square root, so 26. The square root of 26 is AB, and then we want to see what DC is, so I'll write that one up here. DC equals the square root. So DC, our x2 minus x1 is negative 1 minus 3 squared. And then we have plus y2 minus y1, 0 minus 3 squared. So negative 1 minus 3 is negative 4 squared. 0 minus 3 is negative 3 squared. Negative 4 squared is positive 16, plus negative 3 squared is positive 9. 16 plus 9 gives us square root of 25. So 25, we have 26 and 25. So those are not equal to each other. So since they're not equal, we're going to say it's not isosceles. All right, let's take a look at one more property of trapezoids. So the mid-segment of a trapezoid is the segment that connects the midpoints of the legs of the trapezoid. So the midpoints are here. Here's our midpoints, and the mid-segment connects those midpoints, which breaks these legs into two equal parts. So the theorem below, our trapezoid mid-segment theorem, tells us that the mid-segment of a trapezoid is parallel to each of the bases. So it's parallel to each of the bases, and its measure is 1/2 the sum of the lengths of the bases. So if we were to add up AF and CD and then divide by 2, we'd get the length of BE. Let's take a look at an example. So in the figure, LH is the mid-segment of trapezoid FGJK. What is the value of X? So we know that if we add up our two legs, X plus 18.2, and divide by 2, we get our mid-segment, the length of our mid-segment. So X plus 18.2 divided by 2 equals 15. Let's multiply by 2 on both sides. We get X plus 18.2 equals 30. And then we'll subtract 18.2. From both sides, we get X equals 11.8. So this part right here is equal to 11.8.